So this is a top view of the scanner. On the left side here, we can see the camera, and on the right is the actual light source with the rotating specimen in between. The diffuser is just a white sheet of printer paper taped onto a square frame in order to hold it in place. The black strip on top allows for the light to be focused on the specimen, which allows for more contrast in the images. The specimen must be as close to the light source as possible for two reasons. One being that it is the minimum distance the specimen needs to be from the camera in order for it to be in focus, and the other is that the closer the specimen is to the light source, the better it is lit. At the front of the light box, we can see the camera and apparatus. The apparatus allows for the camera to be positioned at the right angle and is made out of PVC piping. The three printed black brackets are used to secure it to the light box. At the back is a circuit and motor, which are connected to a red switch. The motor is wired with a breadboard, and the program is on a Teensy Arduino 2.0 and a stepper motor driver. A 9-volt battery is also used to power the motor, but the battery is not allowed to run in the circuit until the red switch is flipped on. There is a white cord coming out of the left side of the light box and is connected to the Teensy Arduino on the breadboard. This cord must be plugged into a USB port of a computer with power for the motor to be able to run. You'll know it is ready to run when the orange light on the Arduino turns on. The next step is putting the lid on the CT scanner to ensure that no external light enters the system while the scan is being run. Now, we set the camera to the interval timer setting, taking 200 pictures in intervals of 1 second per picture. Also, make sure that the specimen is entirely in frame and in focus so that the scan can be as accurate as possible. Do not press start until the motor is already in motion. Once the camera is ready, go to the back end of the scanner to flip the red switch, allowing the 9-volt battery to power the rest of the motor and setting it in motion. Once that is done, the scanner is ready, so you can select Start on the camera display to run the scan. At the pace set, the scan will take a little over 3 minutes to be fully complete. This is a top view of the scanner with the lid off so that you can see how the specimen rotates once the motor is set in motion. Once the pictures obtained have been formatted according to the instructions, the program is ready to be run. The first display is a black and white movie of all the pictures gathered from the scanner. The white parts in the video represent more dense sections, such as seeds and peels, while the black represents less dense sections. Next, a video cytogram of all the images is obtained to allow for a CT cross-section to be gathered is displayed. Again, the white part represents the more dense sections, such as the peel or seeds, and the black represents the less dense sections. Now, we can see a video of the CT scan cross-section, going from the top down. If you look closely, you can see the seeds of the lemon slice and the peel are displayed in white. Three-D models of the specimen are then obtained and allow for the specimen to be rotated in the X, Y, and Z plane to allow for the best viewing angle. The first 3D scan displays the lighter part of the scan as dark, and the denser part of the scan as light. The next two models display the scan so that the lighter parts of the scan are omitted and the darker parts are represented in color. This type of 3D model allows for the dense parts, such as the seeds and peel, to be easier to view. That concludes the presentation of the scanner and the output images. For further details and references used to develop the project, please see the accompanying PowerPoint.